All right, what up, everybody? This is the AP Calculus practice test for Unit 1, the practice test. This is the free response portion of the test. Now, again, how the test is actually going to be kind of looking is there are free response questions. There's both calculator and non-calculator. And so both of those kind of are rolled into one in this video. However, they will be separated on the actual test. So I'll try not to use my calculator as much as I can, but we'll see. All right, so we begin with number 1, where they want to know some trig stuff. All right, so how we want a unit circle to operate off of. All right, so question A, we want the cosine of 5 pi over 6. So 5 pi over 6 is a small angle close to 1. And so I see that is a big X and a little y. And so the cosine of this would be the X value. So that would be negative square root 3 over 2. Next, we have negative pi over 3. So typically we go in the positive direction, but here we're going to go in the negative direction. And so this is going to be negative pi over 3, so negative big angle. So I see that this has a small x coordinate and a large y coordinate in the negative direction. And again, we want the cosine, which is the x coordinate. Again, points always come in the form of cosine, sine. Right. Okay, moving on to letter C. Letter C, we are asked what is the tangent of pi. So pi is right here, and so that has a coordinate of negative 1, 0. Tangent is also the same thing as saying sine over cosine. So in this situation, the sine is 0, the cosine is negative 1. Thus, this is equal to 0. If it was the other way around, that answer would be undefined because the 0 would be under. All right, next we have secant of 3 pi over 4. So 1, 2, 3 pi over 4 is right up here. And this has square root 2 over 2, sorry, negative square root 2 over 2, square root 2 over 2. These things are also known as 1 over square root 2's. It's the same difference. Okay, so if you rationalize the denominator, you'll come up with a square root 2 over 2. All right, so a secant is the same thing as 1 over the cosine. All right, so if the cosine is that negative 1 over square root 2, that would be the reciprocal of that. So this is going to be negative square root 2. That'd be the reciprocal of that. So that'd be negative square root 2. Last but not least, this is cosecant of negative 11 pi over 3. So they're thirds. So let's count in the negative direction. So this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Here is our negative 11. That's a negative 11 pi over 3. And so what that coordinate is a small x and a large y, both in the positive direction. I want to know what is the cosecant. So that is 1 over the sine. So the sine is 2 over square root 3. So that would be the reciprocal of that. So that would be 2 over square root 3. And then rationalizing the denominator, that would be 2 square root 3 over 3. let me highlight the answers of what we did thus far. It's always a good thing to highlight your answers so you know what, it allows the reader to know what to look at. All right, sketch a graph of each, label the axis point and points of significance. All right, so absolute value is a V. What these manipulations do, this will be left 3, down 2. Left 3, down 2. So left 3, do 3, down 2. And then it's a perfect 45-degree angle, slope of 1 kind of V from here. So I go off the map with arrowheads. All right, this one I don't know. It's nasty. So I want to isolate that Y. So what I'm going to do is I am going to move everything over. So this is going to be 3y is equal to negative x squared minus 6x. Divide by 3, y is equal to negative 1/3 x squared minus 2x. Sorry. What that is, I'm not exactly sure. But what I can do to kind of help myself out is I can factor some stuff. I can factor out a negative 1/3 x. So if I do that, that leaves an x, what, plus 6? An x plus 6. So what I can do is I see that I have definite zeros at 0 and negative 6. 0 and negative 6. So what I can do is I can plot those points. I know that I have zeros at 0 and negative 6. 1, 2, 3, 4, 5, 6. So I know that this is a upside down parabola because this is a negative x squared. And then if I know that those are my zeros, I know that my vertex is going to be on this this x is equal to negative 3. It's in the middle. So what I'm going to do is I'm going to plug and chug a negative 3 into this equation. So y is equal to negative 1/3, negative 3 squared, minus 2 times negative 3. So this is 9, negative 1/3 is negative 3, plus 6, this is 3. So I have a x coordinate of negative 3 and a y coordinate of positive 3. And that's pretty much as good as it's going to get. All right, letter C, I have a sideways parabola, sideways parabola, and then so if y is 0, x is going to be 1, and then and what this is going to do is this is going to open up backwards. So it's going to be a 1, 3, 5 backwards. What I did to kind of determine that is this. What if you made an x2? Is that legal? Are you able to make x2? And so what that would be is y squared is equal to negative 1. Well, that is absolutely illegal. There is no squares that make negative numbers. So this is a parabola, a sideways parabola. It's a y squared as opposed to an x squared. But it will open up upside down. So it'll be a 1, 3, 5 going backwards. Two cosine x plus 3. I don't really want to get into a complete art of graphing sines and cosines. My advice is use your calculator if you can. on these, make a quick and dirty version. But what I do know, like I can graph these pretty well. So what I'm going to do is I'm going to move my center line up 3. That's the plus 3. Typically, a cosine has an amplitude of 1, but that front number is the amplitude. The amplitude is how high and low it goes off of the center line. So this goes up and down to from my center line. A cosine starts at the top and ends at the top. This graph really isn't set up for this, so I'll just kind of make up my own stuff. I'll call this is 2 pi in the x direction. So this is 2 pi in the x direction. And then thus, this is what it would be. Okay, again, I don't think there's too much graphing of sines and cosines without a calculator on the test itself. I think all of that is calculator driven. Yeah. Okay. Letter E is a fancy way of writing a circle. And so here's the process. I have an x squared and a 2x. Okay, I'm going to focus on these, and then what else I have is a y squared and a 4y. This is all equal to 4. Okay. To turn this into a version of a circle, sorry about that. To turn this into a version of a circle, what we're looking for is to construct something that is like x, minus 3 squared plus y minus 5 squared is equal to 16 or something like that. Because what this would allow me to do is identify the center. So the center would be positive, right 3, down 5, and then this is an r squared, so the radius would be 4 in my hypothetical scenario. Now my quest is, how do I turn this x squared plus 2x into something that is a perfect square? All right. And a thing about a perfect square, I'm not sure if I explained this in a previous video, but let's just take this for instance, x minus 4 squared. If I were to truly multiply this out, what this would become is an x squared minus 8x plus 16. All right, so in essence, this number is doubled, and that last number is squared. That's how the kind of quick and dirty version. So if I currently have an x squared plus a 2x, reverse engineer it. What would that second number most likely be? Because if that middle number is doubled, that would imply that in this case, we're going to have an x plus 1 squared. That will create the x squared plus 2x. But what it will also create is a plus 1. All right? Same idea over here. What number would create a positive 4? Well, if it's double, this would be a positive 2. But this would also create a plus 4 if I were to truly multiply those out. So what I have is, in essence, a positive 5 on this side that doesn't exist. So what happened is something minus 5 to eliminate that. Right? So something was minus 5, thus this side would have to be a positive 9. All right? Now, I know there's a lot of weirdo math in there. There's a lot of weirdo math. So in essence, what I'm doing is I'm doubling, or excuse me, halving these numbers to get what the square was. But on these squares, what you have to do is you have to do the opposite to the other side. And so if you're anything like me, you kind of need justification that this is indeed true. So what I'm going to do is I'm going to take this blue number and I'm actually going to multiply it out and turn it back into the original, the purple. So this is going to be x squared plus 1x plus 1 plus y squared plus 4y plus 4 is equal to 4. All right, so this is x squared plus y squared plus 1x plus 4y plus 5 is equal to 4. Sorry. Oh, I'm sorry. This was equal to 9. I'm done. Sorry. 9. I'm running off of this. Is equal to 9. Thus, subtracting 5 from both sides, x squared plus y squared plus 1x plus 4y is equal to 4, which is exactly the original question. All right, so long story short, what did I just create? I created a circle that is left 1 and down 2. Left 1 and down 2. It has a radius of 3. Has a radius of 3. There you go. State the domain and range of x. So the domain, there is no illegal mathematics. So that means negative infinity to infinity. However, the range is going to be a little bit different. What I know is that this is a positive x squared that is down 1. That is a little bit more narrow than the average. So this is the general picture. So I see that the range would be from -1 to infinity. Okay. Number 2, the domain and range of G. So the domain is everything except you can't have illegal mathematics. So what I'm implying is this bottom cannot be equal to 0. I know that that bottom cannot be equal to 0. So that implies that x cannot be equal to -2. So it can be anything in the universe except for -2. So that would be, I'll say all real numbers except x is not equal to -2. Something like that. Oh, real numbers. I think that's a symbol for real numbers. It's like an R with 2 vertical bars. Real numbers. Range. I think this is a one of those dudes that have a horizontal asymptote at 0, but it goes up and down forever. Like this goes to infinity and this goes to -infinity kind of idea. So the range is -infinity to infinity. That's of the g of x. Next, find g of f of x. So g is the big equation, so 3 over x plus 2, and the f is inside that. So that's 2x squared plus 1. So I don't think this is really anything good. So 2x squared plus 3 over 3 is what it is. Letter D, f of x plus h. So f is the big equation, so 2x squared minus 1. And then instead of it being a regular x, it's now x plus h. So this is going to be 2x squared plus 2xh plus h squared minus 1 So bringing in that, so this is 2x squared plus 4xh plus 2h squared minus 1. I think that's as good as it gets. I don't see anywhere to go from there. Last but not least, we have f times g of x. So what that means is that is f, which is 2x squared minus 1 times g of x, which is x plus 3 underneath, or excuse me, x plus 2. X plus 2 underneath 3. All right. So again, I don't know if this is anything good. Numerators multiply numerators, denominators multiply denominators. So this is 6x squared minus 3. Numerators times numerators, denominators times denominators is x plus 2. Yeah, you can make it look different, but it's all pretty much the same. Actually, no, you can't really make it look different. That pretty much is what it is. Again, let me highlight my answers here so I let the reader know this is my indeed full-blown answer. Those are pretty obvious answers right there. Okay. Number 4, find the equation that must satisfy the coordinates of any point whose distance from 4, -2 is square root 2. This is just a fancy way of describing a circle. So if I have this 4, -2, this point, every point is square root 2 from it. All right, so every point is square root 2 from it. So no matter where you look, it has a distance of square root 2. That's a fancy way of saying this is a circle with radius that is equal to square root 2. All right, so equation of a circle. So that's x minus 4, that will move it to the 4. And the y is a -2, so that will be y plus 2. And then this is equal to the radius squared. So square root of 2 squared is 2. So there is the equation that satisfies that every point on the line is square root 2 from 4, -2. Rewrite your answer in interval notation. Okay, one thing that I've kind of learned about absolute values is it's best to just get your answers, or get the important answers, and then see if it's true or not. Like, this is what I mean. So absolute values, what you do is, in a nutshell, is you make the answer positive and negative. So I see here I have both absolute values on both sides. I'm just going to kind of ignore that, and I'm just going to get both answers. So x minus 2 is equal to 2x plus 5, and x minus 2 is equal to -2x minus 5. So I kind of just made the plus minus version of that answer. And what I'm going to do is I'm going to get these important numbers, and then I'm going to worry about that inequality in the middle. So I get all the answers first. So here we go. This is x, so I subtracted the x, and then I subtract 5 is equal to -7. Here I have 3x, I added the 2x, and add to -3, x is equal to -1. All right, so here is where I kind of do my testing of my answers. So I have this interval of -7 and -1. Now, what are the answers in there? So what I do is I kind of test numbers in these intervals. Like, so any number above -1, like the number 0. Any number between -1 and -7, like -5. Any number below -7, like -10. These are numbers, and what I'm going to do is I'm going to test the validity of the original equation. And so, for instance, if I use 0, okay, this is going to be positive 2. And again, if I use 0, this is positive 5. Is that a true statement? Is 2 less than 5? Yes. That is a true statement. And then, now looking ahead, I can, if I know 1, usually, I'm not saying all the time, but usually they flip-flop throughout the problem. So that's kind of what I'm expecting, but I think it's in good order to actually prove it. All right, so testing -5, for instance. -5 would be a -7, so this would be a positive 7. -5 would produce a -10. -10 plus 5 is -5, so this is going to be 5. Is 7 less than 5? No. All right, the last one, using the -10. So the -10, putting it into the original, -10 minus 2, this is going to be 12. -20 plus 5 is -15, thus this is 15. So what I'm saying is 12 is less than or equal to 15. Yep, that is true. All right, so what is my answer in interval notation? Where do I have smiley faces? I have smiley faces from -infinity to -7, and, which is like a U for union, -1 to infinity. That is my valid intervals where this will be true. All right, number 6. Okay, so the first thing that I notice, x cannot be equal to 4, no, nor can it be equal to 5. But other than that, it's all good. All right, so where is this true? All right, so similar to the previous problem, I'm going to see where are my general answers. Notice there aren't absolute values, so all I'm going to do is, in essence, say that they're equal, and then figure it out from there. All right, so with an equal sign, I cross multiply. So this is 3x minus 15 is equal to 2x minus 8. Thus, x is equal to 7. So 7 is the critical number. That's the important number. Now, what I'm going to do is I am going to test numbers that are below 7 and above 7. So like the number would be 0 and 10 or something like that. All right, so 0. 0 would be -3/4, and 0 would be -2/5. Is -3/4 less than -2/5? Yes. That's like saying -0.75 is less than -0.4, which is true. Trying the number 10. This would be 3/6, so that's 1/2. And then 2/5 is 1/2 less than 2/5. This is like saying 0.5 is less than 0.4. That is not true. Okay, so what is the answer to number 6? So I have to describe the smiley faces. Now here is where these things have to also come in play. So my answers are -infinity to 7. I'll just kind of crudely say this, and notice how it's not an or equal to, so it gets a round bracket on the 7. And then also x is not equal to 4 and 5. I just kind of like add that to the answer. All right, so we have this piecewise function for asked to graph. So y is -3 when it's less than 0 or equal to 0. So it gets a solid dot. So there's your 3. Then I have an x -1, so that's a right 1, and then it's a disco, so right 1. So that puts the epicenter right there, and it's going from 0 to 3, so it'd be 1, and then up 8, so it goes up cubes, like 1 is 1, 2 is 8, that sort of thing. So I go up 8, so 1, 2, 3, 4, 5, 6, 7, 8, and then it is the or equal to on that. So there you go. Then that blue dot to the left is an open dot, and then the blue dot to the right is a closed dot. And then last but not least, I have a line. Let's do this in purple. A line. And so I'm just going to kind of plug and chug. So I know that when x is equal to 3, that's -6. So that'll be 6 at 3. 1, 2, 3, 4, 5, 6. Okay, notice it's not or equal to, so it's an open dot. And then this has a slope of -2. There you go. There's your piecewise function. Okay, draw the various transformations. Okay, so this will be a right 2, down 3, right 2, down 3. So right 2, down 3 of each of the critical points. Right 2, down 3, right 2, down 3. All right, so that's that. The middle one, what does the -2 do? What that does is it multiplies every y-coordinate by -2. It multiplies every y-coordinate by -2. So for instance, if this original dot is at -1, this will be at a +2. If that vertex is at +2, that means the manipulation will be at a -4. If that last dot is at -2, that would imply that this would be a +4. And so there's the manipulation of letter B. Last but not least is an absolute value. Absolute value just means if it's negative, you have to make it a positive. If it's positive, it remains positive. So again, this very first dot, which is at -1, is going to be at a +1. And so the line will go down. Okay, this middle part is positive, so it remains positive. So I mimic it. And then this last part, which is negative, it goes to a -2, implies that this would have to go to a +2. So if it was below the line, it becomes above the line. If it was above the line, it stays above the line. So that blue W thing is the absolute value. Okay, this is obviously a calculator question. Write your answer in interval notation. Where is this? Greater than square root 8. So go to my graph. I'm going to say x to the 4th minus 0.3 x to the 3rd plus 2.5 x squared. And then I'm going to also just create another graph of square root 8. Sorry, let me adjust this. Again, if you have like a weird window, like I did something weird to this window before, I'm just going to hit zoom 6. 6 is the standard, and that'll make it a 10 by 10. A lot of times that is a good enough window. All right, so that's my x to the 4th graph. There's my square root of 8. And so I go, I'll use my cursors to kind of show you where I'm doing this. I want to calculate, so this gold writing above trace. So I'm going to go second, calculate, and I want to calculate the intersections, number 5. So I go down to 5 and hit enter. All right, so I'm going to calculate the intersection. So what I'm going to do is I'm going to arrow over kind of to that first intersection, hit enter, it jumps to the other line, enter, hit enter one more time, and it says that it intersects at negative 0.8912. Okay. So what I have right here is I have this parabola, I have this line, and this intersection right there is at negative 0.8912 as far as the x-coordinate. This intersection I still need to find. So again, I go second, calculate, intersect. Okay, but this time I'm going to kind of arrow more over, get my cursor kind of to the other intersection that I want. And that intersects at an x value of 0.9520. So the question is, where is the red line greater than the blue line? Where is the red line greater than the blue line? Well, it would be from negative infinity up into that negative 0.89. So negative infinity, let me change my colors here. Negative infinity to that negative 0.8912. Okay, this is not an or equal to, so it gets a round bracket, on the 89. And then there's more answers, so I do that union symbol again. And it will be, so I described all of this, and now I need to describe all of the line that is bigger than the 0.95. So that would be the 0.9520 to infinity. A particular piece of sheet metal with radius 8 feet is used to create, is used to create a right circular cone. The equation for the volume of the cone is V is equal to 1/3 pi r squared, 64 minus r squared, with radius of r, the cone, okay. So what I'm going to do is I am going to graph this. So when I go y is equal to, okay, in essence, I'm going to be saying y is equal to 1/3 pi x squared 64 minus x squared. That's in essence what I'm going to be doing. So notice what I'm substituting. Y is going to be representing the volume, and x is going to be representing the r. All right, so if I go 1/3 pi x squared on the square root of 64 minus x squared. All right, now ask yourself some logical questions. If I'm making this out of original piece with a radius of 8, what is the biggest radius of my cone? What is like maximum? That would also be 8. The radius of my cone is maxing out at 8. All right, so anything beyond 8 is just phooey. And also, this part of the problem also relegates that, because I know that 64 minus x squared has to be greater than or equal to 0. All right, so that implies that x squared x has to be less than or equal to 8. Don't worry about the negative, but don't worry about that. So it has to be less than 8. So that is part of the domain. So the domain of this R has to be less than 8. All right. Technically, there is nothing else constraining the domain on the low side. However, logic, a logic domain says that a radius can't be less than 0. So logically, this would be it. However, the actual mathematical domain would be negative infinity to 8. Okay, so what am I saying to you? That means if I go to my window, I know that my x min, which is the same thing as my radius, is 0. The x max is 8. All right? So that kind of lowers my window there a little bit. But how high does this go? How high does this go? It goes way up there. I think I may have had you set up your calculators to ask questions. So I'm going to kind of ask my calculator, hey, what the heck is this at 4? And this says it's like 1/16. Well, what is it at 5? Well, let's get bigger. What about 6? What about 7? All right. So it looks just like by plugging and chugging that it's going to max out right around the 200 ballpark. So what I'm going to do is I'm going to go to my window and I'm going to set this like kind of in the 200 ballpark. I'll go 225 or something like that. Dude, there you go. So there is your picture of this. All right, so the picture looks something like this. All right, so important pieces of information. This is at 8, 0. This is at 0, 0. But what is that actual maximum? What is that actual maximum? I'm going to use my calculator to figure that out. So I'm going to, again, go to calculate right up here in the gold. So I go second, calculate. And I want to go to 4, the maximum. It's asking me for the left bound. So what I need to do is just enter any point that is to the left of that maximum. So that point is good enough. Now it's asking me for the right bound. So here I have to arrow over until my cursor is to the right of that top. Anywhere to the right, anywhere. There, that's to the right of the top. Hit enter, and then hit enter one more time for it to quote unquote guess. And it says this tippy top is at 6.5320, comma 206.3701. All right, so what does that mean? That means that, again, this x represents the radius. This y represents the volume. So the maximum volume is 206.3701 cubic feet. Right? Cubic feet. This is the radius. And so the question that is being asked of us right in this question is, what is the radius that will maximize the volume? The radius is 6.5320 feet. And that's it, boys and girls.